So, as somebody who covers STEM and covers gender issues in the workplace, kind of the top line that one might hear is that there are no women in STEM. They're nowhere to be found. It's a huge problem. We got to fix it now. So I think just from looking on stage, we can assess that there's a little more nuance to that, right? So I guess this is where I want to start out. And Maria, I want to start out with you. When we talk about representation of women in STEM fields, in science in particular, have things gotten better?
Yes, I think they have gotten better, which doesn't mean that they are well enough. When I started in the lab way back in the Middle Ages, there were very, very few women. And if you needed women mentors or if you needed examples of women in science, you literally had to go back almost to Marie Curie because there weren't any women that you could point to. But things have changed a great deal. We do see a great attrition of women during their careers because of different milestones in their lives. But we have wonderful scientists now. We have certainly women in all parts of biology, biochemistry, and science. So I think they have gotten a little bit better, but we have a ways to go.
Pardis, what has been your experience working in labs? You know, have you had a wealth of other women to work with, and how has mentorship been?
Yeah, I mean, definitely the vast majority of my mentors and teachers have been men. Mm-hmm. And I think that there's a certain point where you become blind to it. You don't even realize that like all of your classes are taught by men. But I've had some amazing female mentors. Diane Worth, who's an infectious disease researcher, and you know, I did a postdoc with her, and Erin O'Shea, who's my chair, and she's now the president of HHMI. And I have some extraordinary female mentors. And I also, but you know, and some of my greatest mentors are men. So Eric Lander has been an extraordinary mentor to me and somebody who believes very, very strongly in women and promotes women in that way. And now, because I have my own lab, I have lots of women and lots of men. I have just awesome, awesome people in my lab. So it's about creating that diversity of, you know, in always diversity that makes it really fun. So it's true that we have a long way to go, but it's kind of fun to be on that journey with other great women and men.
Yeah, and what was the experience like starting your own lab, and what are you specifically focusing on?
Sure. So the experience starting your own lab is amazing. It's like a startup that you're sort of putting together, and you get to build the culture of it. I mean, and as women, or maybe not just as my own personality, we do things a little bit different. Right now, we're like very deep into our annual holiday card. And if you look at our holiday card, it's like the first year I just went to Kmart and got a whole bunch of like, you know, ugly sweater type stuff and made an eclectic kind of Hanukkah, you know, Christmas, Kwanzaa, like kind of vibe. And now every year, I mean, we've reenacted the Academy of Athens. We've done a whole card underwater. Literally getting scuba gear to make sure it was just right, and so it's been really fun. And it's what's really fantastic about it is that we can create the culture, we can create the environment that we want to work in, and we take our science very seriously, and our science is very serious, working on Ebola and Zika and other viruses like that. But we don't take ourselves seriously, and that's a lot of fun.
Yeah. Jocelyn, I want to stick on the idea of mentorship and guidance. You are a physician's assistant, but you have started your own foundation to take a look at rare diseases. Can you talk to us a little bit more about the foundation that you started and where you looked for guidance as you were doing that?
Sure. So the foundation that we started just a little over a year ago, it's called Cure CMT4J. It's a nonprofit, all-volunteer foundation. And we started it because my 11-year-old daughter Talia was diagnosed with an ultra-rare disease called CMT4J. It's known to affect about 22 people the world over. And in the world of rare diseases, people like myself championing the fight for finding and funding a cure is not an uncommon thing. So we quickly surrounded ourselves with researchers throughout the world who knew Talia's disease the best and the mutation involved in her disease the best as well. And you know, we're really pushing those channels of science. We were told that if we were to wait for someone else to take on the possibility of gene therapy to treat Talia's disease, that we might be looking at 8 to 10 years down the road, and we just didn't have that kind of time. CMT4J has caused Talia to become wheelchair bound. She's lost the use of her arms, and she now also has respiratory involvement as well. Our preclinical work right now, one of our researchers there, Kat Lutz at the Jackson Laboratory, she has really sort of partnered with me to also be a champion for this disease, CMT4J. And I think part of the reason for that is that she's a mom, and I think she really gets what we're doing, as well as the other researchers that we have involved.
Yeah. So as you're getting this diagnosis and kind of coming to terms with that and how horrific that must be, you're also then deciding, I'm going to take this on my own and figuring out how to build a foundation and to raise money to get this done. Who was the person who guided you along? Was there anyone to do that?
You know, we, unfortunately, the world of rare diseases, it is really the parents and family members who, again, have to take on the task of finding and funding a cure. So I feel as though all of those parents and families and patients before us have paved the way for us. So there wasn't really any one person that I looked to. You know, we just sort of tried to use what worked and didn't work for other rare disease foundations out there. And we're hoping to drive there as fast as we can.
Yeah. I want to talk a little bit about the availability of funding for research and how much of that goes to women. I think, Maria, you've said before that this is one of the best times to be doing scientific research. Can you tell me why you think that, and then also what your take is on how many of the research projects being funded are actually women scientists?
Why do I think it's one of the best times for science? Well, because we have simply, you know, there's a famous saying by Federico Fellini, which is that you pull a little tail and you find an elephant on the other side. And I think that's what happened with the human genome. We pulled a little tail, and all of a sudden, the world of biology and of physics and of chemistry opened before our eyes. And whether it's on Zika, or in my case, tuberculosis, or cancer, or diabetes, or in rare diseases, we now have the tools to really look and explore at the cause of disease, the etiology of disease, and ways to figure out how to prevent it and how to treat it. We've never had this amount of information and this amount of power within our grasp. So I think it's incredibly exciting. One of the things that we need to maintain and continue, of course, is the public commitment to funding research. The number of women applying for grants is growing, but it's not, again, you need to have a cadre of women coming through the pipeline in order to do that. And I think we have to make sure when we talk about funding that we not only talk about the amount of funds available at the NIH, or actually there's a new group of funders, which are the people who have specific diseases that have happened in their family. So there's a lot of philanthropic funding for basic research these days. We need to be able to tap that. But in order for women to get in the queue, they have to start early on. And we see a lot of attrition. So I want to go back not only to the funding, but I want to go back to the pipeline of women coming through that allows us to enhance the number of people that are applying for grants, the number of women, and in my case, minority women that would be working on research.
Pardis, what has been your experience of seeking funding or trying to find funds to do research for yourself or for others?
I mean, it's a grind,
yeah.
And it's a grind for everyone. And I think it's a struggle, to be honest. I mean, and I don't know, you know, I always say it's not like, sometimes you get in this point where you're like, darn it, because I'm a woman, you know, because you just feel as if it's like the wall is against you. And then there are other times where you're like, it's like one parameter. It's like one feature among many. And it's really hard to see. Definitely, I've, you know, took a major hit after the Ebola outbreak. And a lot of the funding went into sort of that, you know, multi-billion-dollar federal commitment. But the problem with that commitment is actually it's not run. Like, I like working with the NIH because I kind of know what I have to do, and there's some unknowns, but ultimately I get it's transparent, it's merit-based. There's a lot of kind of recourse, whereas a lot of the money that comes from other places, like in the philanthropic or in the defense world, you have no idea why they're making the decisions that they're making, and so it's a struggle. And I think the best way to fix anything is through transparency, meritocracy, like very clear guidelines, because you then never do know. I think the worst, we were sort of talking about is it. Obviously, it was the women who came before us worked a lot harder and had much bigger struggles than we did. But the problem that we have is the insidious nature of things, right? Because you start being like, is it me or is it them or what is it? Like, you don't know. If you just knew the world's against you because you're a woman, that would be easier to handle sometimes than being like, what is it? Why don't they like me? And it might be just they don't like you. So you just don't know. And I think that's the frustrating part.
I will say that a lot of scientists, male or female, feel that way. It's probably me, or they have something against me, because the number of grants that you're able to fund are so small and the competition is so intense. So I think we have to be very careful that it's not because you're a woman or you're not a woman. Science rules, and science has to rule. Are there biases in review? Possibly. Why do people make decisions that they do? At the end of the day, if you're a philanthropist, it's your money, and so it is what it is. So you need to be realistic about that. But if you have good science, solid proposals, and the ability to get things done and to move the needle, the problem really is that you have demand and limited amounts of funds.
Do you think it's a numbers game? Do you think the problem is essentially that there just are more male scientists who are submitting?
To a certain extent, I think that's true. To a certain extent.
And Pardis, do you feel like the issue is just that there's a lack of transparency, so it's hard to tell?
Yeah, it's not. That's the thing. It's like if you tell me like school was I really always like school, because it's like I just know what I'm supposed to do, and I think that world we live in just fine. It's when we get out into the world of what is it that I'm not doing that you start to struggle. And the more we have transparency and meritocracy and clarity, the more we can deal with it, right? And I think that's one of the reasons I like the NIH is because it's one of the places where you get much more of that. Whereas in other spaces, you just don't know.
Yeah.
So I will say, and I want to talk about the rare diseases, at the Foundation for NIH, we do funding. We don't have our own money. We always look for projects that we are able to secure the resources to do it. And then we fund research around the world. And frankly, to be perfectly honest, we're completely agnostic whether it's a man or a woman. What we want is the best research out there. And we actually scout proactively to make sure that that's the case. And it's particularly difficult in the space of rare diseases, where you really have very little science to go to, and you need the basic of research in that space.
Jocelyn, I actually wanted you to talk a little bit about the difference, or kind of the unique experience that you have trying to get funding for a rare disease. I think you said 22 people in the world have. Talk to me a little bit about trying to convince people to give money to this cause.
So funding is our greatest challenge. The world of rare diseases, I think that is its greatest challenge, is receiving the funding. It's very difficult to convince a pharmaceutical company to take on a disease that affects 22 people the world over. However, we are hoping to really convey a message to people that this isn't just about this one rare disease. Our tagline is advancing gene therapy for rare diseases, and our philosophy is really that as we tackle all of these single gene diseases, the path to get there will become easier and cheaper with every one. It's almost like that domino effect, that if we tackle one, the next one we get to tackle that much more quickly. It was Mary Lasker, I believe, who said, if you think research is expensive, try disease. And that's the other message that we're trying to convey as well, is that if we don't treat these rare diseases, the expenses involved in trying to maintain a life of disability for a person is incredibly expensive. And gene therapy really has the unique opportunity of one injection, one treatment, one cure, and away you go.
Yeah. Do you feel like people are receptive to that message? Do you feel like you're getting through to them?
I feel like more and more gene therapy is being looked at as not so much an anomaly, but a real hope for the future for not only rare diseases, but many cancers out there as well. we're using gene therapy in over 600 clinical trials right now, and we have an amazing number of success stories that are coming out from SMA to blindness. So I really think that we're really at a stepping off point right now.
Yeah. Maria, you talked a little bit about the challenge of kind of being able to tell from the science whether or not a rare disease research effort is something that you guys should fund. What would you need to see? Is there any way to bridge the gap between kind of the rarity of the disease and the inability to kind of have a wide sample size and the clear necessity of dealing with these things?
Well, it is a difficult task. I faced similar challenges when we were developing medicines against tuberculosis. Not in this case because there weren't enough people, but because it was a disease that affected poor populations that couldn't pay. So at the end of the day, it's an issue of economics. You spend the same amount of money developing a drug for tuberculosis or for a rare disease than you do for a cancer, where it might be a lot more profitable. So we have to face that reality. One of the ways that you can bridge that gap is to figure out if there are common elements, if the target of the potential therapy can also attack other diseases. So then you start making the economic be more feasible. So let's say you find a pathway in the disease progression that you can tackle. And if you tackle that point, there are other diseases that you can affect. And so that's one possibility, that these rare diseases do actually help point to other interventions that would also be very helpful. So finding that link is important.
Right. I want to go back and talk a little bit about the makeup of the field. Maria, you mentioned attrition, and Pardis, I want to talk to you a little bit about how you think about attrition of women scientists in the field. Has that been something that you've seen a lot, and what do you kind of think the issues are leading to attrition?
Yeah, I definitely, if I think back to who was there with me when we started and where they are now, for certain there's a lot of attrition. And and I think I almost, there are so many times when I was almost bailed out, and I'm always ready to maybe retire with my parents in Florida and be like, I'm out of the game. It was a good run, and we're all set. But I think it's hard. You have to make a conscious choice all the time. And I remember at one particular point where I was the closest to just being like, I can't do this anymore, and it was a really hard part after I'd started as a faculty, and everything seemed to be up against me. And one of my female employees basically said, this is your defining moment. And it's not for you, it's for every other person that will come behind you. If you bow out, then what hope do we have? And I thought that was it was a really strong statement, and I've always kept it with me. And so there are so many times where we want to drop out, but if we want to create the world, that we hope for, and we hope for our daughters, and we hope for, for all the future generations, and we stick with it. And I think the biggest thing is about solidarity. So the women that did stay with me, I think, we get together and we talk about things, and you say, boy, do you know what just happened to me? And something really that feels great about that, right? When you can just kind of talk about what happened. And hopefully, bit by bit, there'll be less of it over time.
Yeah. Maria, what do you think the causes of attrition are, and how can we deal with them?
Well, so doing science is hard. Being in the lab is hard. I don't know that it's harder than other professions. Certainly there's people that do law or finance, et cetera, that spend the same amount of time and hours. It is a profession in which you don't get to see the immediate result of your work. So you need to have the ability to understand that you're starting a marathon and that it's going to take a long time for you to get the result. You don't find a drug the minute you walk in the lab, or in many instances you don't want to. You just want to do science because you want to answer basic questions in biology or basic questions in earth science or whatever it is. So women then find a partner, they might get married, they have children, and so balancing the work-life balance is hard to do. So having the support in the group of friends, having the support of mentors, having the support of your partner and your family is particularly important. Now, I speak as one who bailed out, technically. One day I woke up after my second postdoc and I said, I don't want to be in the lab. So my husband, who's also a scientist, said, what do you mean you don't want to be in the lab? I said, I don't. But I didn't want to be divorced from science. I loved science. I loved the quest. I understood the ethos of scientists. I was one. So what I tried to do is figure out what you could do as a scientist that would have an impact on science while you weren't in the lab. So the point I'm making is that even with a science degree, you can have tremendous influence on science if you're not in the lab. So for the women who decide, I don't want to be in the lab, there are many, many careers. You can go into policy, you can go into foundations, you can go into sponsoring research. There are many activities, or even in venture capitalists, where you can understand what people are doing and how you can use your expertise. So don't be disappointed if you don't want to stay in the lab, because there's a world out there that needs the scientific knowledge.
Yeah. So I have another question or two for our panel, but then we do want to open it up to the audience. So if you could start thinking about and condensing your questions now, and also making sure that they're questions and not comments, that would be lovely. So I want to pick up on the thread that Maria just brought up about persistence. You know, we are talking about trying to find breakthroughs, not just, you know, kind of incremental change, but incremental change is so much of what science is, right? So Pardis, I guess you'd be a great person to start with. Talk to me about kind of the persistence that's necessary to keep going as you work towards that kind of big breakthrough.
Sure. I think that well, you do. You have to be persistent, you know, ruthless, essentially, and not in your passion for what you're doing. You have to be totally just mesmerized by the question of what you're trying to do or what you're trying to solve, because there are so many different things that are kind of come at you to tell you it's just not worth it, you know. And so I think that is really important. And for us, during the Ebola outbreak, we were persistent because we had friends on the front lines, and we were passionate about making sure that the world knew what was going on as fast as possible. And we wake up in the morning because we're passionate. We still don't think we're ready for the next outbreak, and I get excited. I go to sleep at night thinking about it. I wake up in the morning with ideas about it. I mean, that's what you have to be excited about it, because, like I said, the world will tell you it's not worth it. And I think you have to have a set of colleagues. Amy Cuddy is a good friend of mine, and she's going through her trial and challenge, where the world is telling her what she's doing is not important, and I think it is. I think that we're crazy to think that our bodies don't affect our minds and the way that we interact and however we go about it. I mean, she's persistent and passionate to understand what's going on there. And so the solidarity with other people who have the things that they want to pursue and that want to be able to do it is amazing. And I think that's how we get through.
Jocelyn, I mean, persistence, I don't think even really begins to describe it. You received kind of some devastating news and basically said, no, I don't accept that. I'm going to change everything to fight against that. Can you talk to me about how you got to that place after receiving such a blow, and how you kind of keep coming back to that point of just being persistent and trying to fight towards this breakthrough?
Sure. You know, it's interesting, having been practicing medicine for 20 years, when we received Talia's diagnosis, there was a part of me that I knew where to find the information, and I was pretty frightened by the information that I found just on one quick Google search on her disease, CMT4J. And it actually took me a couple of weeks to really wrap my brain and heart around this, and to put on, you know, not my mom hat, but my clinician hat, and say, okay, we're just going to look for whatever we can. We were told there was no treatment or cure, but my husband and I said, you know what, there has to be something out there. And we ultimately found a researcher who said, yes, in fact, you know, gene therapy may be a possible cure for your daughter and others. And it's really Talia and her ability to bring so much joy to our lives, despite the devastating effects of this disease. She's really the person behind all of the persistence that I have to use and face every single day with, as well as the other children and families that have found us through our fight to cure CMT4J as well. And, you know, just like Pardis was saying, you know, I I wake up thinking about it. I go to sleep thinking about it, and I honestly don't sleep very much because it wakes me up in the middle of the night as well. It's really trying to fight time and funding in order to get there as fast as we can.
Yeah. I want to make sure we get some audience questions in, so if you could put your hands up high so the runners can see you, and we will start right back there. Sorry.
Yeah. Hi, my name is Shinny. I'm originally got my PhD in neuroscience and now transitioned into a career in policy through AAAS. I'm at USAID. So I'm going to try and keep this short, but it does require a tiny bit of background, which is we know that when you go into undergrad biology classes, there are more women than men. And as you go through the stages and each point in the career, whether it's graduate school or postdoc or PI, you lose women along the way. Now, I'm not trying to say that becoming a professor is the only job that you can get with a PhD. However, when you look at professorships, you do see that there are more men than women, and that has been consistent. But you guys have made it in different careers and gotten to different positions. So I want to know what you think the barriers are and how did you overcome them, and what kind of environment are you trying to create now that you are at the top to prevent it to keep happening to other people along the way?
Got it. Pardis, you want to?
Sure. So I often tell people, so quick kind of side to your point, which is being a professor is not the end-all be-all, and it's not. I think one of the mistakes we make about the training that we do for scientists is assume that it's a pyramid scheme to professorships, and there's too few of them. There's too few of them, and they're not, like I said, it's not all cracked up to be, I promise you. And so I think that, I'm glad we're training more undergraduates in biology. I'm glad there are more people going to graduate school, and I hope that more, like I love PhD training because it makes you think about a hypothesis, test that hypothesis, do controls, and I'd love to see PhDs in our Congress, and I love to see them in all sorts of leadership positions. But when it comes to why are we losing them? I think, like I said, we're losing them because there's so many places where you wake up and you say, I'm out of the game. It is hard, and research is, your daily job is failure, right? And that's sort of how, and you have to basically always shake off whatever's going to come at you and just enjoy the issue. And I think that there are, like I said, there's all these little things. It's sort of like the death by 1,000 like duck bites or whatever, that kind of idea that it's all of the little things that keep coming. And the more we can pick away each of them, the more we'll have places where people don't say, I gotta step out of the game. And the culture we create is, I said, I have as many women and men in my lab, and I create a nurturing environment for them. And the more women we have that get to higher positions, the more women they will hopefully, and not all, some of my best mentors are men, and not all women support women, and that's an important issue we all have to think about. But we can continue to create that culture. And we're seeing massive changes right now in culture in Hollywood and elsewhere, and I think that comes with more women being strong and empowered and willing to speak up and to take control, take ownership of what they want.
Yeah. And I think we had a question over here.
Hank Wallace of Write and Speak Like the News. Will scientists win more of those budget money competitions if they do justice to their science by sounding confident? That is, we need reliable data. Sounds like a reasonable thing to say in trying to get budget money. And yet, in a sexist environment especially, people often diminish their own science by qualifying it gratuitously and by putting a question mark at it. So we need reliable data becomes out as, I think we need reliable data.
Okay. Do any of you want to hop on that?
Well, you've hit on something. I don't know that I'll answer your question or your comment directly, but you have hit on something that I've noticed, and particularly in women. And I mentor a lot of women, and I enjoy mentoring both men and women. But one of the things I always say to women is, you have to understand your worth. Not overstated, not understated. And you have to learn to wield your power. Women often think they have no power, and they always think they're victimized. You have to get that power and exercise your power. And when scientists by nature always qualify their answers because they know that the next generation of scientists is going to either destroy what they just said or not, so they like hedging it. But there's ways of saying things that give the public and give the person that hears a sense of comfort and confidence that you've done the best you can with the information you have. So for women in particular, learn to wield your power in an astute but thoughtful way, and learn to assert your own worth. And that's hard to do.
All right, I think we had another one over here, somewhere in the front.
Yes. Hi, I'm Shalina Chalani. I'm the associate editor at Education Dive. I was really interested in your discussion about the pipeline, and I wanted to ask specifically, where do we start in the pipeline? How early are we supposed to start targeting girls? Do we go all the way to early childhood education? And what exactly are we targeting?
We work very closely with people, and we give an award called the Lurie Prize. And Anne Lurie, who sponsors the prize, is very keen on knowing and understanding how we put this pipeline together. The data shows that in middle school, even in early education, boys and girls have the same thirst and interest in science. But the attrition happens sometimes in middle school and high school, and you start seeing that attrition go down quite dramatically. What we don't do is self-discovery, and this is one of Anne's points. You don't do self-discovery of who ought to be a scientist. So you normally see, oh, he or she should be a scientist in a room, but there are many children who could be scientists, who have the potential for being scientists, but that's never open to them as an option or an idea that they could be the scientist. So keeping that interest throughout the high school, throughout the K through 12 education is critically important. Once you're there, once you have somebody at that stage, you will probably find that they'll go into a science degree, undergraduate, etc. And then the other big jump, as was said earlier, is between college and graduate school. So.
Pardis, you had a thought on that?
Yeah, I mean, I remember like when I was applying for faculty positions, every place I went to, some female professor said, can you come and talk to my middle school daughter because she doesn't think science is cool, and maybe you can convince her. And it was right at that age, as all these little girls that were so good at math, and then middle school, it's just like they're told not to. And I think that is really disturbing. And I think also in America, I love the U.S. I'm an immigrant, I'm a refugee, but I love America because of so many things. But one thing I find so surprising about it is that we are obsessed with the idea of being cool. And being cool means being good at sports and being funny and being pretty. But the one thing it has like a negative association with is being smart. And that is just strange, or being accomplished, or caring about your work. And these little girls, they get this impression that if they start to show an inkling that they like math, that somebody won't like them. And I think that's something we have to make a conscious choice to change, because we're going to really drive out a lot of young people out of the sciences and out of a sense of wanting to have self-worth in their accomplishment and in their academic achievement and beyond. And so I think that's one of the reasons why I stay in it, because I think it's important that they see that, it can be fun. And I love talking to middle schoolers and giving them a hard time about it too. So,
everyone, please join me in thanking our panel.